In this video, we're going to go over some mixture and alligation problems, like this one. So, number one, 4 liters of a 20% acid solution was mixed with 8 liters of a 50% acid solution. What is the concentration of the mixture? So before we actually do the calculation, let's talk about it. Let's see if we can ballpark the answer. If we mix a 20% acid solution with a 50% acid solution, the concentration has to be somewhere between 20 and 50. Wouldn't you agree? Now, the midpoint or the average of 20 and 50, if you add them up, 20 plus 50 is 70 and divide by 2, that's 35. The average is 35%. So here's a question for you. Do you think that the concentration of the mixture will be 35%, somewhere between 20 and 35%, or between 35% and 50? What would you say? Well, it's not going to be 35%. And here's why. The amount of the 20% solution that we're using and the amount of the 50% solution are not the same. Here we have 4 liters and here we have 8 liters. If they were the same, the concentration of the mixture will be right in the middle, which would be 35%. So if we had 4 liters of the 20% acid solution mixed with 4 liters of the 50% acid solution, then the mixture will be 35%. But now, do you think it's going to be between 20 and 35 or between 35 and 50? Notice that we have more of the concentrated solution. So because we have more of the 50% solution and less of the 20% solution, it stands to reason that the average will be somewhere between 35 and 50. So let's see if we can get that answer. Now what we need to do is calculate the weighted average. And in this case, the weighted average is going to be the volume of the first solution, which is 4 liters, times the concentration of the first solution, plus the volume of the second solution, which is 8 liters, times the concentration of the second solution, which is 50%, divided by the total volume. So V1 is 4 liters, C1 20%, V2 is 8 liters, C2 50%, and then V1 plus V2, so that's 4 liters plus 8 liters, which is 12 liters. So as you can see, the unit liters will cancel, giving us the value in percent, or the concentration in percent. Now let's do the math. 4 times 20 is 80, and 8 times 50. 8 times 5 is 40. Add the 0, so 8 times 50 is 400, divided by 12. Now, 80 plus 400 is 480. 48 divided by 12 is 4. So 480 divided by 12 is 40, if you add the 0. And so this is the answer. This is the concentration of the mixture. It's 40%, which we said it's between 35% and 50. So when you have mixture problems like this, you can ballpark the answer by looking at the relative amounts of solutions that you're adding. And so in this case, it's closer to the 50% solution rather than the 20% solution. Now let's move on to number 2. The average test score of 40 men in a classroom was 80. The average test score of 50 women in the same classroom was 92. What is the average test score of all students in this class? Now, once again, we need to calculate a weighted average. Whenever you need to calculate an average, basically you need to take the sum of something and divide it by the number of things in that sum. In the last example, the weighted average that we used to calculate the concentration of the mixture was based on this formula, V1 C1 plus V2 C2 over V1 plus V2. In this example, we're going to use a formula that's very similar to this, but with different letters because the words are different. In this case, the total sum of the scores of all men in his classroom is going to be T1 times N1, where T1 is the average test score and N1 is the number of men in the classroom. And then T2 is going to be the average test score of the women in the classroom, where N2 is the number of women in the classroom, divided by the total number of students. Now, focus on the basic idea behind this equation. So this right here represents the total score of all men in the classroom. And this term, T2N2, represents the total score of all women in the classroom. So when you combine these two expressions, you get the total sum or the total score of all students in the classroom, divided by N1 plus N2, which represents the number of students in the classroom. And that corresponds to N in this expression. But as you can see, these two equations, this one and this one, they look very similar, just the letters are different, but the design of the equation is still the same. So let's go ahead and calculate the average. So I'm just going to rewrite the formula so you can follow along. Now, T1, we said that the average test score for the men in the classroom, which is 80. N1 is the number of men, that's 40. And T2, that's the number of women in the classroom. No, I take that back. That's the average test score of the women in the classroom, so that's 92. N2 is 50. And then N1 plus N2, that's going to be 40 plus 50. So now let's do the math. We have 80 times 40, which is 3,200. And then 92 times 50, that's 4,600. And then 40 plus 50 is 90. 46 plus 32, that's going to be 78. So 7,800 divided by 90, we could cancel a 0. So it's 780 divided by 9. And so the average test score is 86.6 repeated, which we're going to round that and say it's 86.7. And so that is the average test score of all students in the classroom. Now let's see if our answer makes sense. Let's think about it conceptually. So here on the left we have men, and on the right we have women. Now the average test score for the men was 80, and for the women was 92. Now the number of men is 40, and the number of women is 52. Now the midpoint between 80 and 92 is 86. So if we had an equal number of men and women in a classroom, the average test score should be 86, because 86 is the average of 80 and 92. However, notice that we have more women than men. So therefore, the average is between 86 and 92. Now, these numbers, 40 and 50, they're not far off. Because they're pretty close, the average is close to 86. But if we had a lot more women in the classroom, the average will be closer to 92. Now, let's move on to number 3. A 30% salt solution was mixed with a 40% salt solution to produce 16 liters of a 36.25% salt mixture. How many liters of the 30% salt solution was used to make the 16-liter mixture? Well, let's write down the information that we have. So we have solution 1, solution 2, and the mixture. So what do we know? We know that the concentration of solution 1 is 30%, and the concentration of solution 2 is 40%. And we know the concentration of the mixture, which is 36.25%. So basically, we have C1, C2, and the concentration of the mixture. What we don't know is the volume of the first solution or the volume of the second solution, but we do know the volume of the mixture. Now, here is a question for you. Do we have more of solution 1 or more of solution 2? Which one is greater, V1 or V2? Now notice that the concentration of the mixture is 36.25%, and the midpoint between 30 and 40 is 35. So because this number is closer to 40, we should expect that V2 will be greater than V1. So I'm going to write that down. So we need to find the values of V1 and V2. If we get our answer where V1 is greater than V2, we know something is wrong. So just by analyzing this problem mentally, we know that V2 has to be greater than V1. But how do we go about calculating these two volumes? What do we need to do? Well, it's always nice if you have an equation to work with. And let's go back to the equation that we had. We said the average, or basically, in this case, the concentration of the mixture based on problem 1 is V1C1 plus V2C2 divided by V1 plus V2. Now, when you add the volumes of solution 1 and solution 2, you're going to get the volume of the mixture. So we could say that V1 plus V2 is basically the total volume of the two solutions, or the volume of the mixture. Now what we need to do is multiply both sides by the total volume. And so these will cancel. And we're going to get this equation. So we're going to get an equation that looks like this. C1V1 plus C2V2 is equal to the concentration of the mixture times the total volume. So this is just another form of writing the weighted average equation. Just it's been modified to fit this particular problem. So now, what else do we need to know? Or, what should we do at this point? What we should do is call V1x. And V2, what is V2 if V1 is x? Well, we know that V1 plus V2 is equal to the total volume, which is 16. So, if V1 is x, what is V2? If we move x to the other side and solve for V2, you'll find that V2 is 16 minus x. So I'm going to write that here. And in order to solve this problem, it's important to replace V1 with x and V2 with 16 minus x. If you don't do this, this problem will become a lot harder. So make sure you understand what I just did. If you don't understand it, feel free to pause the video or rewind it and watch that part again. C1 is 30%, V1 is x, C2 is 40%, V2 is 16 minus x, the concentration of the mixture 36.25%, and the total volume 16 liters. So now let's do some math. So this, we're just going to write this as 30x. By the way, you can convert 30% into 0.30 as a decimal, but you don't have to. Leaving it as 30 or 0.30 will not change your answer. So personally, I prefer not to deal with decimals if I don't have to work with them. So I'm going to leave it as 30x rather than 0.30x. Here we're going to distribute. So let's multiply 40 by 16. And so that's going to be 640. And then we have 40 times negative x. So that's negative 40x. And 36.25 times 16. I typed that in wrong. Let me retype it again. That's 580. So let's combine like terms. We have 30x minus 40x, which is negative 10x. This number, I'm going to move it to this side. So on the right side, it's 580 minus 640. 580 minus 640 is negative 60. And then if we divide both sides by negative 10, negative 60 divided by negative 10, that's 6. So x is equal to 6. (16 minus 6), if you replace x with 6, that will give you 10. And so we can see that these two numbers, they add up to 16, which is good. And we can see that V2 is greater than V1 because the concentration of the mixture is closer to 40% than it is to 30%. And so that's also a good sign. Now let's go back to the problem. What was it asking? What is it asking us to solve for? It says how many liters of the 30% solution was used to make the 16-liter mixture. So the volume of the 30% solution is 6 liters. So this is our answer. That's what we're looking for. Number 4. The price of sugar ABC is $4 per kilogram, and the price of sugar XYZ is $5 per kilogram. In what ratio should the two types of sugars be combined in order to create a mixture worth $4.60 per kilogram? So how can we determine the ratio in which the two types of sugars should be mixed to get this price? How can we do that? Well, this problem is actually similar to the last problem. Recall that the equation in the last problem that we used was C1V1 plus C2V2, which is equal to the concentration of the mixture times the total volume. But in this case, we're going to change the variables. We're going to use the letter P to correspond to the price and the letter N to correspond to the quantity. Now, we don't have any quantity values in this problem. Perhaps kilograms could be the quantity, but we don't know how many kilograms the mixture contains or anything like that. So because we don't have any values for the quantity, we're going to use percentage to represent the quantity. Thus, our modified equation becomes P1 N1 plus P2 times N2 is equal to the price of the mixture times the total quantity in the mixture. So P1, that's $4 per kilogram, and P2 is 5, and the price of the mixture is $4.60. But now what is N1, N2, and N total? Well, we know that N1 plus N2 has to equal NT. And NT, because that's a percentage, we could say that NT is 100%, which as a decimal value, that's simply 1. So if N1 is X, we have X plus N2, which is equal to 1. If we take X, move it to the other side, we get that N2 is going to be 1 minus X. So that's what you need to take from this. NT is 1, N1 is X, and 2 is 1 minus X. Using that, we can solve this problem. So let's replace P1 with $4 per kilogram. N1 is going to be X, P2 is $5 per kilogram, N2 is 1 minus X, and the price of the mixture, $4.60 per kilogram, and NT is 1. So now let's do the math. This is going to be 4x, 5 times 1 is 5, 5 times negative x, that's negative 5x, and this is just 460. So we have 4x minus 5x, that's negative or negative 1x, so plus 5, that's equal to $4.60. Subtracting both sides by 5. 460 minus 5, that's negative 40 cents, or negative 0.4. Now, if we divide both sides by negative 1, we get that x is 0.4. And so that's basically n1. Now, n2, which we said was 1 minus x, that's 1 minus 0.4, which is 0.6. So now let's go back to what we have. Keep in mind, n1 is x, n2 is 1 minus x. So here we have sugar ABC and sugar XYZ. So the price of sugar ABC is $4 per kilogram, and for XYZ it's $5 per kilogram. Now, N1, which corresponds to sugar ABC, is 0.4, which as a percentage, that's 40% if you multiply it by 100. Now, sugar XYZ is 0.6, or 60% if you multiply that by 100. Now, let me put the mixture. So the price of the mixture is $4.60 per kilogram. And the quantity is 100%, because if you add 40 and 60, you get 100. Now let's see if this makes sense. Notice that we have more of the expensive sugar and less of sugar ABC. So because we have more of this sugar, the average is closer to 5 than it is to 4. So that makes sense. Now, how can we take these values and turn it into the answer that we're looking for? Because we're looking for the ratio in which the two types of sugars should be combined. So what is the ratio between a quantity of sugar ABC and sugar XYZ? So the quantity of ABC is 40%, and the quantity for sugar XYZ is 60%. So we could ignore the percentages. If we get rid of the 0, we have the ratio 4 to 6, and we could divide both numbers by 2. And so the ratio becomes 2 to 3. So we need to mix 2 parts of sugar ABC with 3 parts of sugar XYZ to get a mixture with a price of $4.60 per kilogram. So this is the ratio that we need. That is the answer. Number 5. A 500 gram saltwater solution consists of 30% salt. How many grams of pure salt should be added to make it a 40% salt solution? So what should we do in this problem? Now in chemistry, perhaps you have taken that class already, the solute plus the solvent combined together makes up the solution. In this example, the solute is salt. The solvent is water because water dissolves salt. When you mix water and salt together, you create a solution. Now, we have the mass of the solution. That's 500 grams. Right now, we don't have the mass of the salt, nor do we know the mass of water. However, we do know that these two, they have to add up to 500. Now, what else do we know about this problem? We do know the percentages. The solution is 30% salt. Now, the entire solution equates to 100% of the value because the solution represents everything. But the portion of the solution that is salt is 30%, which means the other 70% consists of water, and 30 plus 70 is 100. So in order to calculate the mass of the salt in a solution, we need to find out what 30% of 500 is. So what is 30% of 500? Well, if you want to do this mentally, first find out what 10% of 500 is. 10% of a number, all you need to do is take the decimal, move it 1 unit to the left. So 50 is 10% of 500. Now to find 30%, it's important to see that 30% is 3 times 10%. So 3 times 50 is 150. So we have 150 grams of solute. Now 70% of 500 is simply going to be 7 times this number. 7 times 5 is 35. So add the 0, that's 350. So the mass of the water is 350 grams. And 150 plus 350 adds up to 500. Now let's focus on what we're trying to do. Our goal is to calculate the number of grams that should be added, that is the number of grams of salt that should be added to the solution to make it a 40% salt solution. So if we increase the mass of the salt, this should go up. So how many grams of salt should we add to make this number 40%? And it's important to understand that as you add salt to the solution, the mass of the solution will go up as well. The only thing that's not going to change is the mass of the water. In part A, it's going to remain 350. So what do we need to do at this point? It's always good to write an equation. The mass percent of a solution is basically the mass of the salt, or the mass of the solute, divided by the total mass of the solution, times 100%. Now the mass of the solution is the sum of the mass of the salt plus the mass of the water, times 100%. So this is the formula that we have that we could use in order to get the answer. The mass percent that we want to achieve is 40%. So let's write 40% here. And then we have the mass of the solute, which we'll talk about later. Now the mass of the water, that's 350. This is not going to change. So at this point, we could put 350 here. And then times 100%, which I'm running out of space. So let's get rid of this. Now, what should we write for the mass of the solute? Because if we put 150, then this equation won't work. This should be 30%. So it can't just be 150 alone. Now remember, we're going to increase it by some unknown value. So it's going to be 150 plus the number of grams of pure salt that we're adding to make the mass percent 40%. So that unknown amount that we're adding, we're going to call it x. So ms in this expression, or in this problem, is 150 plus x. So now the equation on the right becomes 40% is equal to 150 plus x divided by, now we have ms on the bottom again, so that's another 150 plus x, plus the 350 that was already present, times 100%. So what we're going to do is divide by 100. So 40 divided by 100, that's 0.4. And that's equal to 150 plus x. And here we can add 150 and 350, which will give us 500. So we have 500 plus x. Now I'm going to turn this into a fraction. So that's going to be 0.4 over 1. And now let's cross multiply. So 1 times 150 plus x, that's 150 plus x. And then we have 0.4 times 500 plus x. 0.4 times 500 is 200. And then we have 0.4 times x. Don't forget to distribute. So that's 0.4x. Now let's subtract both sides by 150. And let's subtract both sides by 0.4x simultaneously. So these will cancel. And so what we have left over is x minus 0.4x, or you could say 1x minus 0.4x. And that's 0.6x. And then we have 200 minus 150, which is 50. Now, starting with that equation over here, the last thing we need to do is divide both sides by 0.6. And 50 divided by 0.6 is 83.3 repeating. Now let's check to see if our answer makes sense. So we're going to increase the amount of salt in a solution by 83.3 grams. So let me separate the old data from the new data. So the new mass of the solute is going to be 150 plus 83.3. So this is a rounded answer. That's 233.3. The exact answer should be repeated. Now the mass of the water, that's not going to change. That's going to remain 350. Now the solution is going to be the sum of these two values. So 233.3 plus 350, that's 583.3. So now we can calculate the mass percent. So the mass percent will be the mass of the solute, which is 233.3, divided by the mass of the solution, 583.3, times 100%. So you should get like 39.99657, which is basically 40%, which means this is 60%. So if we did 350 divided by 583.3 times 100, that will give us 60%, and this is 100%. And so we have the answer. The answer, though, is 83.3 grams. So that's the mass of, that's how many grams of salt that we need to add to the old solution to increase the concentration from 30% to 40%. Now let's move on to part B. How many grams of pure water should be added to make it a 20% salt solution? Well, let's write this again. The salt plus the water will give us the solution. So we have the same information initially. We have 500 grams of the solution, 350 grams of water, and 150 grams of salt. Now, going back to part A, we added salt to the solution, and so the mass of the salt went up, but the mass of the water didn't change. However, the percentages did change. The percentage of the salt in the solution, it went from 30% to 40%. So the concentration of the salt increased. Now the concentration of the water decreased. It went from 70% to 60%, so it went down. Now for this particular problem, we're going to add water to the solution. And so the mass of the water is going to increase, but the mass of the salt in the solution will stay the same. Now the percentage of the salt, even though the mass of the salt is remaining the same, the percentage will go down. Initially, it's a 30% salt solution, but we want to dilute it to a 20% solution. And so the concentration will decrease if we add water, if we dilute it. Now the concentration of the water is going to go up. The water concentration was 70%, but by adding more water, it's going to go up to 80%, because these two, they have to add up to 100. And so it's important to understand how the percentages will change, even though not all quantities will change. So now let's go back to the equation that we had before. So that was the mass percent is equal to the mass of the salt divided by the mass of the solution, which is the mass of the salt plus the mass of the water, and then times 100%. So the mass of the salt is going to be 150. That's not going to change. However, the mass of the water will change. It's 350 plus the additional number of grams of pure water that we're going to add to it. So it's going to be 350 plus x. And here we have times 100%, and the desired concentration that we want is a 20% salt solution. So that's going to be the mass percent in this example. So let's begin by dividing both sides by 100. So 20 divided by 100 is 0.20. On top we have 150, and here 150 plus 350 is 500. So let's write 0.20 over 1, and let's cross multiply. So 150 times 1, that's 150, and then we have 0.20 times 500 plus x. So 0.20 times 500 is 100, and then we have 0.20 times x, which is just 0.2x. Subtracting both sides by 100, 150 minus 100 is 50, and that's equal to 0.2x. Next, we need to divide both sides by 0.2. So 50 divided by 0.2 is 250. So this is the additional number of grams that we need to add to decrease the concentration from 30% to 20%. So let's write the new values. So the mass of water is going to be 350 plus 250, which will give us 600 grams. The mass of the salt will be the same, but the solution will increase. It's 150 plus 600, which is 750. So the mass percent of the new salt solution is going to be the mass of the salt, which is 150, divided by the mass of the solution, which is 750, times 100%. So 150 divided by 750 times 100, that's 20. And so that confirms the answer for this problem. Now the answer is not 20%, but the answer is x, which is 250 grams. So this is how many grams of water that we need to add to the solution to decrease the concentration of the salt solution from 30% to 20%. Now, before we move on to the next problem, I want to mention that if you haven't done so already, feel free to subscribe to this channel. And don't forget to click on that notification bell. That is, of course, if you like this video. Also, when you get a chance, check out the description section of this video, as I'm going to post some other links to videos that you might be interested in. I do have other topics like algebra, trig, chemistry, physics, so I have playlists on those topics if you need help in those subjects. So feel free to check the videos in the description section below, and let's get back to this problem. Number 6. The price of cotton is $14 per kilogram, and the price of linen is $35 per kilogram. If the two materials were combined in a 5:2 ratio, what will be the price per kilogram of the mixture? So go ahead and take a minute and work on this problem. If you want to, feel free to pause the video. So let's write down the information that we know. So the first material is cotton, the second is linen, and here we have the combined mixture. Now we're given the price of cotton, which is $14 per kilogram, and the price of linen is $35 per kilogram. Our goal is to calculate the price per kilogram of the mixture, so we can call that X. That's what we're looking for. Now, this problem is very similar to the problem that we did in number 4, where we came up with this equation. P1 N1 plus P2 times N2 is equal to the price of the mixture times the total quantity of the mixture. As you can see, the variables correspond to this particular problem. Now we know that P1, the price of the first material, is $14 per kilogram. P2, the price of the second material is $35 per kilogram, and the price of the mixture is X. Now what about N1, N2, and N total? In problem number 4, we said that N represents the quantity. Now, because we don't have the amount of kilograms of the mixture or of the cotton or of the linen, we use the quantity as a percentage. But in this example, we're going to use the quantity as a fraction. You could use it as a percentage if you want to, but for this particular example, using fractions is going to be easier, and you're going to see that. Now let's focus on the combination of the two materials. They were combined in the 5:2 ratio. So what does that mean? So this is basically a part whole problem. We're going to take 5 parts of cotton and mix it with 2 parts of linen. So the mixture contains a total of 7 parts. So N1 is basically 5 out of 7. N2 linen is 2 out of 7. The mixture is 7 out of 7, which is 1. So as a percentage, 1 is 100%. Now, the fraction 2 over 7 as a percentage, if you divide 2 by 7 and then multiply by 100%, you'll get 28.57%. 5 over 7 as a fraction is 71.43%. So you could use percentages or fractions and you could still get the right answer. But I'm going to use 5 over 7 for N1, 2 over 7 for N2, and 1 for N total. As you can see, 5 over 7 plus 2 over 7 adds up to 1. So now let's plug in everything into the equation. So N1 is 5 over 7, N2 is 2 over 7, and NT is 1. So what's 14 times 5/7? It's best to divide before you multiply. 14 divided by 7 is 2, and 2 times 5 is 10. Here we have 35 divided by 7, which is 5, times 2, that's also 10. And x times 1 is just x. So x is 20 per kilogram. And so that is the price of the mixture, $20 per kilogram. Now let's see if our answer makes sense. So the price of cotton is 14 and the price of linen is 35. If we were to average these two numbers, if we add up 14 and 35, which is 49, and then divide by 2, the midpoint is 24.5. Now notice that the quantity of cotton is greater than the quantity of linen. For every 5 parts of cotton that we add to the mixture, we're going to use 2 parts of linen. And so because this is the more abundant material, the average should be between 14 and 24.5. And the average price is between those two numbers. So this answer makes sense. Number 7. An alcohol-water mixture exists in a ratio of 2 to 1. 6 liters of water was added to the mixture, causing the ratio to change to 4 to 5. What is the volume of the original alcohol-water mixture in liters? So feel free to try this problem. Well, let's write down what we know. So this is before adding water. The ratio from alcohol to water is 2 to 1. And then we're going to add 6 liters of water. Once we do that, the ratio changes from 2 to 1 to 4 to 5. So how can we turn this into an equation in which we can solve for the volume of the mixture, the original alcohol-water mixture? Well, let's say that W, which is the volume of the water in the original mixture, we're going to say that it's X. If that's the case, then A has to be 2X because it has to be in a 2-to-1 ratio. So if W is 1X, A has to be 2X. Now, once we add 6 liters of water to the mixture, the amount of alcohol doesn't change because we're not adding any alcohol. So on the right side, the alcohol has to remain 2X because it has to stay the same. We're not changing it. W is going to change. We're adding 6 liters to W. So W is now its original value of X plus 6. So we could say W is X plus 6. Now we can write an expression using the information on the right. If we divide A by W, it should equal 4 over 5 because the ratio of A to W is 4 to 5. Now, we can replace A with 2X and W with X plus 6. So we have 2X over X plus 6 is equal to 4 over 5. Now our goal is to calculate X. Once we have X, we can calculate the volume of the original alcohol-water mixture. The volume is going to be the volume of the alcohol plus the volume of the water. So that's going to be A plus a W. Now A is 2X, W is X, so the volume of the entire mixture is 3X. So once we calculate X, all we need to do is multiply it by 3, and that will give us our final answer. So let's solve for X. So it's going to be 4 times X plus 6. Don't forget to distribute. So that's 4X, and then 6 times 4 is 24. And then that's going to be equal to 2X times 5, which is 10X. Subtracting both sides by 4X, we have that 24 is equal to 10 minus 4, which is 6, or 6X. And dividing both sides by 6, we can see that 24 divided by 6 is 4. So X is 4. So now let's understand what we had at the beginning. Since X is 4, that means that the amount of water in the alcohol mixture was 4 liters. The amount of alcohol is 8 liters. So 8 to 4 gives us a ratio of 2 to 1. Now once we add 6 liters to the mixture, the amount of water becomes 4 plus 6, or 10 liters. The amount of alcohol does not change. Now 8 to 10, if you divide both numbers by 2, you get the ratio 4 to 5. So that makes sense. And if we add 8 plus 4, that means that the original volume of the mixture, that means alcohol plus water, is 12 liters. Or if we replace X with 4 into the expression 3X, so 3 times 4 will also give us 12 liters. So this right here is the answer. That is the volume of the original alcohol-water mixture in liters. A milk-water solution with a ratio of 7 to 3 was combined with another milk-water solution with a ratio of 1 to 4. Find the ratio by which the two solutions should be mixed in order to create a milk-water mixture with a ratio of 65 to 135. So let's write down what we know. Here we have solution 1, and we're going to mix it with solution 2, and that will give us the mixture. Now the ratio of the first solution, the ratio of milk to water, is 7 to 3. For the second solution, the ratio is 1 to 4. And for the mixture, the ratio of milk to water is 65 to 135. Now the formula that we need to use in this example is C1V1 plus C2V2 is equal to the concentration of the mixture times the total volume. Now, the concentration, we can write that as a percentage or as a fraction. So a 7:3 ratio tells us that it's 70% milk, 30% water. So the ratio is 7:3:10, part whole. So as a fraction, you could say that the concentration of the milk is 7/10, and the concentration of the water is 3/10. But I'm not going to use fractions in this example. I'm going to keep the concentration as a percentage. Now what about a 1:4 ratio? So the whole is 1 plus 4, which is 5. 1/5 is 20%, and 4/5 is 80%. So this is 70% milk, 30% water, 20% milk, 80% water. Now 65 plus 135 is 200. So if you take 65 and divide it by 200, that'll give you the percentage of milk in this mixture, which is 32.5% milk. And 135 divided by 200 will give us the concentration of the water, which is 67.5%. Now here is a question for you. What should we use for C1 and C2? Should C1 be the concentration of the milk? Or should it be the concentration of the water? Or should it be a combination of both? Now, you can get the same answer if you use C1 as the concentration of the milk or C1 as the concentration of the water. It doesn't matter. You can't use both, or at least you shouldn't. So you just got to pick one. Just use milk or water, whichever you want, and you should get the right answer. But we're going to use the concentration of the milk. So C1 is going to be 70%, C2 is 20%, and the concentration of the mixture will be 32.5%. You just have to focus on one component of the mixture. Everything else will work out. Now what about V1, V2, and the total volume? We're going to say the total volume is 1 whole, or 100%, because we don't have any information that tells us the number of liters of milk or water. So we're going to use a standard value of 1 to represent the whole or the entire mixture. So we're going to say V1 is X. So what should V2 be? Remember, V1 plus V2 is equal to the total volume. So if V1 is X and VT is 1, V2 has to be 1 minus X. C1 is going to be 70%, V1 is X, C2 is 20%, V2 is 1 minus X. The concentration of the mixture for the milk component is 32.5%, and VT is 1. So now let's solve for X. So this is going to be 70X, and then we have 20 times 1, which is 20, 20 times negative X, and this is 32.5. So let's combine like terms. We have 70X minus 20X, which is 50X. Moving this to this side, that becomes 32.5 minus 20, which is 12.5. Now our next step is to divide both sides by 50. And so 12.5 divided by 50 is 0.25. So now we have our answer. Well, not quite, but we're almost there. So X is 0.25, which means V1 is 0.25. V2 is 1 minus 0.25, which is 0.75. So now we can write the ratio between solution 1 and solution 2 is 0.25 to 0.75. If we multiply that by 100, that gives us 25 to 75. Then, if we divide that by 25, this will give us a ratio of 1 to 3. So this is the answer. Now, if we wish to confirm the answer, here's what we can do. We can do a weighted average. Let's do it with the milk. So this is 1 to 3 to 4, part whole. So the amount of the first solution is 1/4. We're taking 1 part of solution 1 out of a total of 4 parts. 1 plus 3 is 4. And then the concentration of milk in the second solution is 20% times the quantity of solution 2, so which is 3 parts out of a whole of 4. So 1/4 of the mixture consists of solution 1, and 3/4 of the mixture consists of solution 2. So if you type this in, 70 times 1/4 plus 20 times 3/4, that will give us the concentration of the milk, which is 32.5%. Now we could confirm the other answer. So let's focus on the water. In solution 1, the concentration of the water is 30%, and solution 1 is 1/4 of the mixture. In solution 2, the concentration of the water is 80% times the fact that solution 2 is 3/4 of the mixture. And so if we type this in, 30 times 1/4 plus 80 times 3/4, that will give us the concentration of the water in a mixture, which is 67.5%. And so the answer has been confirmed, which means that the ratio by which solution 1 and solutions 2 were mixed is 1 to 3. We took 1 part of solution 1 and mixed it with 3 parts of solution 2 to get the mixture with these concentrations. That is the concentration of milk and water in the mixture. And so that's it for number 8. And that's basically it for this entire video. So I'm going to stop here. And whatever you do, don't forget to subscribe to this channel. Hopefully this video was educational, and I hope that you found it to be useful. And if you did, feel free to subscribe and click on that notification bell. And also check out the links in the description section of this video. I'm going to have some other videos that you might be interested in. Thanks again for watching.